Okay, so this is a key to Worksheet 1 dealing with topic 18, part B. And in particular in these problems, you're focusing more on the vertical stretch and shrink as well. So that's where that part B comes in. So part B has to do with that vertical stretch, vertical shrink. So that was the focus of part B. Okay, so let me go ahead and rewrite that function g of x here so we can talk about that. So g of x is negative 3 square root of x. All right, and so the problem says this. The problem says, um, describe how the graph of the function g of x, which is negative 3 times the square root of x, can be obtained from the basic graph. So remember, my basic function, my parent function, is a square root function. So f of x is equal to the square root of x. So that is my basic function, or my parent function, okay? And the graph of the parent function looks like this. So if you were to graph it, this is what it would look like. And so remember how we did this. So remember, you can only take the square root of a positive number or 0. So when I use the t-table, on here, if x is 0, the square root of 0 is 0. And I used nice numbers for x. These square roots, I'm using perfect squares. So when x is what? When x is 4, I get the square root of 4, which is 2. So there's the point 4, 2 right here. See it? So that's the point 4, 2. If x is 1, I get the square root of 1, which is 1. So there's the point 1, 1 right here. If x is 9, I get the square root of 9, which is 3. So there's that point 9, 3 right here. Okay? And so there's your graph. So that's the graph of the parent function. All right, now, here's something you got to remember. So there are two things occurring here, and you got to notice this. You have to notice this. So if you need to kind of cover some stuff up as you go through this, then you do that. But I want you to notice, here's the parent function, right? And so the next thing you're doing is you're multiplying this parent function by 3. And then this negative out here means reflection. So that's a reflection about the x-axis. But let's talk about that 3 for a moment. Okay, so remember this right here. So remember, I can rewrite this as g of x is equal to negative 3 times f of x. Okay, and the reason I'm saying f of x, because isn't that what f of x equals right here? So f of x is your parent function. And remember, the f of x means the same thing as y, right? Okay, so what that says is this. What that says is I am going to multiply all my y values by 3. That's what that says. So when x is 0, my y value, let me do it this way so I can show you. So when x is 0, so I'm going to use the same x values here, 0, 4, 1, 9. This time when x is 0, my y value is 0. So 0 times 3 is 0. 2 times 3 is 6. 1 times 3 is 3. 3 times 3 is 9. Okay? Kind of makes sense because watch. When x is 0, what's the square root of 0? 0. And what's 0 times 3? 0. When x is 4, what's the square root of 4? 2. What's 2 times 3? 6. When x is 1, what's the square root of 1? 1. What's 1 times 3? 3. See that? Okay. Now, so what I want you to notice is this. When I look at my at these points here on the graph, so 0, 0 stays 0, 0. So I plot the point 4, 6, which is here. I plot the point 1, 3, which is here. And then 9, 9, which is here. Okay, 9, 9, which is here. So this right here is y equal 3 square root of x. So I want you to notice is that this graph here is being stretched vertically. So whenever you're moving the graph away from the x-axis, I'm taking the parent function, moving it away from the x-axis. That's called a vertical stretch. And I want you to notice that the way we got this is that we took each of those y coordinates each of these y coordinates and we multiplied it by a factor of 3. So this number right here in front of the parent function that you're multiplying the parent function by is your vertical stretch or shrink. So since this is 3, and when I multiply each of those y values by 3, the graph moves away from the x-axis. If it came towards the x-axis, it would be a shrink. So that was something you learned in your lessons. So this will be a vertical stretch. All right, so when we do this part here, you're going to say, start with a graph of f of x, then stretch vertically by multiplying each y coordinate by 3. That's what that says, and that's what we did here, right? That's what we did here. We took each of these y coordinates, multiplied by 3 times 3. Did this, multiplied by 3 times 3. Did this, multiplied by 3 times 3. Did this, multiplied by 3. And that's how we get these. Okay? So that's what that number in front implies. So this right here, now you got to cover this negative. This right here says I take each of those y coordinates and I multiply by 3. All right, and so that's going to be a vertical stretch. Now the negative out here, remember what that means? The negative out here is a reflection. So that's a reflection. So then the next thing you're going to do is this. So finally reflect it across. You got to remember though, when you reflect it, it's reflected across this negative out here is a reflection across the x-axis. So reflect it across the x-axis. So basically what's going to happen now is this. So look carefully. So you're going to take each of these points now. You're going to take each of these points and you're going to reflect it about the x-axis. So 0, 0 stays 0, 0. That stays 0, 0. 1, 3. This point 1, 3 becomes, remember the opposite. When you reflect it across the x-axis, this point is 3 units above the x-axis. You're going to go 3 units below. So it becomes a point 1, negative 3. So that's this point here. This point here, which is 4, 6, becomes a point 4, negative 6. 4, negative 6, right here. And then this point here, which is 9, 9, 9, 9, becomes a point 9, negative 9 when you reflect it across the x-axis. So 9, negative 9 is right here. And so now you get this. So this is your final graph right here. So that would be, what do we call it? Called it g of x equal negative 3 square root of x. So g of x equal negative 3 square root of x. So that's what that looks like. Now in number 1, they didn't ask you to graph it, but that's what you go through. All right? That's what you go through. Okay. Now look at number 2. So number 2, we have g of x is 1/4 this time times the absolute value of x minus 3. So 1/4 times the absolute value of x minus 3. So you want to graph this using transformations, and we use a basic function. So my parent function, remember, is going to be the absolute value of x. So let's kind of look at what our parent function looks like. Okay, so this is our parent function. Remember, that's f of x equal the absolute value of x. All right, remember how we got this. So we got this by doing this. Let me just remind you. So if x is 0, the absolute value of 0 is 0. So that's this point here. If x is 1, the absolute value of 1 is 1. So 1's right here. See it? If x is 2, the absolute value of 2 is 2. That's this point. So we draw our ray, do the same thing here. If x is negative 1, we get the absolute value of negative 1, which is a positive 1. So you see this point here? If x is negative 2, we get the absolute value of negative 2, which is a positive 2. See this point here, negative 2, positive 2, and then you just draw your ray. So there's the graph of my parent function. But I'm going to go ahead and draw it on here, though. So let's do it on here. So you're going to start with the graph of h of x, which is absolute value of x. So 0, 0, 1, 1, 2, 2, looks like this. Over here, negative 1, 1, negative 2, 2, looks like this. Okay? All right, so that is h of x. Now they called it h of x here, so let's call it h of x. So that's my parent function. Okay. Now, remember, there are two things occurring. Two things occurring. Let's cover up this part here. Remember, the negative 3, that's that vertical transformation. Always do that last. So that's a vertical transformation. You are multiplying the parent function by 1/4. Here, you are multiplying the parent function by 3. So remember, when it was multiplied by 3, you were stretching it vertically. And we saw what happened when we did this. Let's think about what's happening here. So you're multiplying this parent function by 1/4. Now let's talk about what that means. So let's look at what that means. All right, so listen carefully. So all I'm going to do right now is just look at this part here. Y equal 1/4 after value of x. Okay? So if I look at the, and let's call this f of x right here. And so if I look at my parent function, which is this, and I look at all of these y coordinates and these x coordinates. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is negative 1, y is 1. When x is negative 2, y is positive 2. Now remember what this says. This says I take my parent function, okay, which is h of x here, and I multiply it by 1/4. So remember, this means the same thing as y, right? So that means I take each of these y values and I multiply by 1/4. That's what that says. So I take all the y values of my parent function and I multiply by 1/4. So when I do that, I want you to notice what happens. When x is 0, 0 times 1/4 is 0. When x is 1, 1 times 1/4 is 1/4. You all agree? 1 times a fourth is a fourth. When x is 2, 2 times 1/4 is 2/4, which is 1/2. When x is 1, when x is negative 1, excuse me. My y value, 1 times 1/4 is 1/4. When x is negative 2, 2 times 1/4, 2 times 1/4 is the same thing as this one, so it'll be 1/2. Okay? So what I want you to remember is this. When we did number 1, we saw that this 3 moved my parent function away from the x-axis. So it's being stretched vertically. Okay? Let's look at what happens here. Watch what happens here. I'm going to plot these points here. And by the way, you could have gotten these by just doing this. Watch. But the whole point was that you have to know that I'm taking that parent function and multiplying these y values by a fourth. And so just verify that this is this. When x is 1, what's the absolute value of 1? 1 times a fourth, 1/4. See this right here? When x is 2, the absolute value of 2 is 2, which is what this is. 2 times a fourth is 2/4, which is a half. And that's what you're doing. So this says now that if I plot these points right here, 0, 0 is here. 1 1/4, you can't see very well, but 1 1/4 is right here. Okay? 2 1/2 is right here. And so I get this. I didn't draw it very well. 2 1/2 is right here. All right, so I get something that looks like this. Okay? And over here, I get negative 1 1/4. So negative 1 1/4 is about here. And then negative 2 1/2 is about here, and so I get this. Notice this, I'm taking my parent function and I'm moving it towards the x-axis. When you move it towards the x-axis, that's called a vertical shrink. A vertical shrink. Okay? All right, vertical shrink when you move it towards the x-axis. So one thing that you learned in that lesson, in those lessons, was this. Whenever the number you're multiplying y by is greater than 1, see this is 3. Don't say negative 3. The negative is a reflection. Deal with that as a reflection. By 3, so whenever this number is greater than 1, it's a vertical stretch. Whenever this number is less than 1, 1/4 is less than 1, right? It's a vertical shrink. All right, so then we're going to start with the graph of h of x, which is the absolute value function. Then we're going to shrink. Use the word shrink here, shrink. Shrink it vertically by a factor 1/4, And then finally, this negative 3 says I'm going to shift it down 3 units. Down 3 units. So I'm going to take all these points here. I'm going to go down 3 units. 1, 2, 3. 1, 2, 3, which is about, let's see, about right here. 1, 2, 3. That's this. Same thing here. 1, 2, 3. And then 1, 2, 3. So this right here is g of x, which equals 1/4 absolute value of x minus 3. All right. So that is the key to topic 18, part B.